Hello, let's see for the details of the next part. Watch carefully. When a statement is true for a natural number n equals k, then it will also be true for its successor, n equals k plus 1. Let's start with this regularly. P of n is equal to 1, plus 2, plus 3, and so on, till n, which is equal to n times n plus 1, divided by 2. Then we will assume that n is equal to k. We get k times k plus 1, divided by 2. And also, the successor must be true for n equals k plus 1. We add k plus 1 after k on the left-hand side, and we have to prove that the right-hand side is k plus 1 times k plus 2, divided by 2. First of all, start with the terms of k, that is k times k plus 1, divided by 2. Then add k plus 1, and factorize the numerator by the multiple of 2. This becomes k times k plus 1, plus 2 times k plus 1, divided by 2. Then we get k plus 1 and k plus 2, divided by 2. That gives the proof. Another example, by taking sum of odd square numbers equal to sum of cubes, that is n cubed. We write 1 squared, plus 3 squared, plus 5 squared, and so on, till we write 2n minus 1 in the entire squared, equal to n cubed. Same way by putting k, which can be true, that is 2k minus 1 in the entire squared, equal to k cubed. And the successor must also be true to prove the following. In this square term, we write 2k plus 1 after simplifying. Then solving this by the way. K cubed plus 2k plus 1 in the entire squared. Then we prove the following to get k plus 1 in the entire cubed. That's all I have. Like, comment, and subscribe now on YouTube.